So let me first start by turning my slides down here and just opening up my web browser. And what I wanted to show you was if you Google summer school and Sharcnet, you will get the link to the website. It's down here, 2018, of course, is the one. You can see it's a regular event we have every year. Actually, there's 3 separate events across Ontario. The first one is the Sharcnet one, which is known as the West Summer School. And it is, let me pick program here. Yeah, so it's at Western University this year. So in the last couple of years, we've had it at Waterloo. So we move it around every couple of years because you tend to get a lot better attendance from the local university. But there's also later in June, there's going to be one in Toronto at Sharcnet, so you're welcome to attend that one as well. And then in July, there will be an East one at Queen's University as well. And there will be some overlap of topics, but not entirely. So it's good to look at the program. You can click the program here and click on any of these courses, and it will give you a description. So as I said, this summer school is at Western, so I want to just cover a few specific Western things here. We have a travel information here. And I want to point this out to you as well. You may be interested, if you're from another university, doing some carpooling, in which case you can contact us to help facilitate that. We're limited in what we can do with that regard because of the legalities. We can't be having to be responsible for it. But yeah, so if you're looking into doing some carpooling, give us a contact. Now, what I'd wanted to show you, if we Google Western, and well, let's look at Western student summer accommodation. There's a couple places. There we go. So, of course, the students. First of all, there's a lot of you can do a lot of short-term rentals or stays because a lot of the students all sign 1-year leases for their buildings, so they're interested in subletting them out or having people stay on the weekend during the summer because they're not there. They'd like to make some of their money back, so that's an option. And the university, of course, their residencies are pretty empty too. So Ontario Hall and London Hall are available. You can check into there for a reasonable price. And now Western parking is a good thing to talk about as well. So if we Google Western parking, we get the parking visitor services here. Where was I? Find parking, there we go. So we bring down the map and we'll download the Western map here of the parking. And I'll show you those 2 residency halls I mentioned as well. So here's the London Hall and the Ontario Hall, I believe they were. So the Ontario Hall and the London Hall. And also, if you have some money you want to spend, there's Windermere Manor up here, which is very nice to stay at. And they're affiliated with the university, so I think if you mention to them that you're attending an event at the university, you can stay there as well. That's quite a bit more pricey, though. Anyway, so that was all the sort of overview I had wanted to give. So let's get into the courses because time is ticking on this. So it's a full week of courses. And the courses are a full day, and then we are teaching 3 simultaneous streams. So on the first day here, we have a course on Octave and metagenomics, assembly and such, and Python. And then our core courses traditionally from the past are message passing interface, so that's MPI, which runs over 2 days, so that's 2 full days. And you'll definitely need to attend the first day in order to attend the second day. Although you could slip out and attend something else in the second day. And then CUDA is the GPU programming, so it's that one. And then as another option, these tend to be a lot harder core programming courses, the MPI and the CUDA ones. There's R and Cloud and Singularity. And then on Thursday, we're into OpenMP, which is also a fairly traditionally core course. We're just doing it in 1 day though, so that's pretty specific. There's C++ as well, which is a pretty specifically aimed course as well. And then there's PairView, which is a more generic course. And then Friday we have Debugging Profiling, detailed look into Fortran, and then some machine learning, sklearn and TensorFlow. So let me get into more detail here. So here's our day number 1. Our first option is Octave. This is going to be taught by James, who's one of our Sharcnet staff from UIT. He'll be coming down for that. So Octave is an open source MATLAB clone, and this is important because MATLAB is encumbered by various license issues, which can make it difficult to run on the clusters depending on where you are and what your licensing is. So Octave isn't frequently a good alternative. It's just a free download. You can install it on your computer, no licensing or anything, and it duplicates quite a large amount of the functionality of MATLAB. So James is going to be going over using Octave code on Graham to run your MATLAB code, and he's also going to be looking into improving the performance of your code and profiling it and different ways you can write your loops and stuff, and the sort of performance implications that will have. So if you're a MATLAB person, we certainly have lots of MATLAB people, or you're interested in that. MATLAB's a very nice high-level language for doing math in, and sees a lot of use in engineering and other areas. Come to this. James' interesting background. He did brainwave studies and stuff, so EGG or ECG, maybe I'm saying it wrong, so it'll be an interesting course. And then at the same time, another option is we have a bio stream. We have a lot of people using bio. So, I should mention too, if you went to the previous course, it's important that you install Octave on your computer before coming to this course, because all our courses are very hands-on courses. So you're going to be wanting to bring your laptop, and for some of them, if there's a note you want to install a particular piece of software, all of the software asking you to install is free software, so you can do that. Please install it before the course, have that set up. So we have Armin is going to be teaching our bio course. He has a lot of expertise on bio pipelines and such. If you've had bio questions, you've undoubtedly been in contact with him. So you're going to do a one-day hands-on session of a metagenomics pipeline, and using the common tools to do gene assembly and such, and showing up how to set that up on your HPC environment. So this is an excellent course for people who are getting started in biology. This is the sort of thing you could really use knowing how to do. And a lot of bio computations are intensive, a lot of searching and a lot of combining and stuff. So you make really good use of the high performance computing facilities. So I would highly recommend that for all bioinformatics students. And then simultaneously, we also have a course on Python taught by Pavel from the University of Waterloo. Python is, I think everybody knows what it is. It's the language to learn of this particular decade. So this is going to be going over Python, and particularly how to make your Python programs run fast. And of course, it's going to be covering NumPy, which is the common sort of matrix language. It's basically sort of the MATLAB of Python, right? It gives you access to matrix operations and can do all your linear algebra and read in your comma separated value tables and such. And then so if you can use NumPy to solve your problems, that's great. Your code will be fast. And then some cases though you cannot, and Python on its own is not necessarily a particularly fast language. It's an interpreted language. So in these cases, there's a program called Cython, which will compile your Python code into some C code, which will run much faster. So Pavel will be covering that as well. And then a brief overview of running parallel programs on the clusters. So now we move on to our second day, well, our second and our third day for our first two options here. So as I mentioned, MPI is the classic core course. So our clusters are actually called clusters because they're composed of many computers. And for big problems, you have to use many computers to solve them. So you have to write your programs and they have to communicate with each other across the computers. So the de facto standard for doing that is known as the message passing interface. So that's what this course is going to be covering. It'll be a hardcore C, C++ sort of Fortran core, because that was the original high performance computing. So this is a very good course to attend if you are interested in doing that sort of core, more traditional programming on the clusters. And it's all through hands-on exercises and such. So at the end of this course, you will be ready to embark on writing your own MPI program. You have sufficient to know how to set it up and do the operations and some of the things to be aware of. Now, following that up, we have the CUDA course is the other option going on at the same time. CUDA is one of the GPU languages, the one developed by NVIDIA. This has become very popular in the last several years since, I'm trying to remember what the original application was, but they had realized that graphics processing, the one you use to run your display, had advanced to the point where they were actually very powerful. And they're very parallel because they usually compute all the pixels at the same time on your display. So that people have since managed to leverage them to do their scientific computing, and it turned into a business model for NVIDIA, so it's now officially supported. And they have this language called CUDA, which is sort of a C, C++-like language for writing that. So this course here is going to be going over that. And again, many hands-on details, and as well, each new generation of GPUs, if you're really into this stuff, comes out with new features and stuff. So our instructors are going to be discussing some of the new features that are available with the Graham Cedar GPUs, which are Graham Cedar being our two newest clusters here at Compute Canada. And as with the MPI course, this will be sufficient to get you started developing your own GPU applications. So if that's something you're interested in, or you see yourself going down there, that's a very good course to attend. Now, along with Python being a very popular language, another popular language is R, especially in the bio and the stats fields. So we have Marcelo, who is actually coming down from Scinet, so Toronto, is going to be talking about R. So for this class here, we're going to want to install R or RStudio onto your computer. And then he's going to be covering R in quite a bit of detail here. So he's going to be building up. So there's sort of two different ways you can teach a programming language, sort of a top-down or bottom-up sort of approach. And he's going to be giving you lots of details of sort of the structure of R. And in particular, data frames. If you've used R before, data frames are the key thing. That's what you bring your tables into, and you do your tabular manipulation and such. So he's going to be covering that, and then he's going to be getting into some scripting and doing some basic statistics and writing your own functions and stuff. And if he has time as well, going on and covering plotting and that sort of item. So R, if you're interested in R, and you'll know from your discipline, probably if you just talk to your supervisor, the sort of language. Usually it's a R or Python if you're not into the lower level C, C++, CUDA, MPI sort of thing. Then you'll want to attend this R course or the Python. Or because the Python course was on the first day, if you're into the higher level languages, you could attend the Python, and then you could come and compare it to R on the second day. So that's a good option there. Now on the third day, of course, we're going to have the continuation of the MPI and the CUDA courses. So as I said, if you're going to attend the second day of those, you will want to have also attended the first day. So you could bail after the first day if you want and go attend the Cloud and Singularity course. So traditionally our clusters, this is taught by our own Ed, so he's going to be coming out to teach that. Traditionally our clusters have been an environment that you logged into and you told the computer what command you wanted it to run. You put it in a queue, you logged back out, and then at some point it went and ran that job, and then you went and got the output files back from it. So That's one way of running things, but it's quite a bit different than what some of our users, like frequently people want to set up portals, or they'd really like to have their own instance of a web server to run something or items like that. So this has come into prominence recently with called cloud computing, where you basically get a virtual machine on the internet, and then you can manage it and set it up as you like. Very common now with like the Google Elastic Compute Cloud, the EC2, or the Amazon Cloud, or the Microsoft Azure Cloud. So we're also breaking into the cloud infrastructure sort of thing, because this is what our users would like, some of our users would like. So Ed's going to be going over our cloud offering. So the basics of deploying a cloud instance, so that's your virtual machine and setting it up, and even more advanced topics getting into running a web server and then setting that up to interact with the cluster. So you can make quite nice portals to provide access to actual computing results back on the cluster side. So now on Thursday, we're going to be a full stream. This is quite a bit more like the Monday stream. We're on our core courses. Number one, our first option is going to be OpenMP. So OpenMP is a compiler specification. Actually, it adds a certain number of statements you can add to your source code to identify portions of your source code that the computer can run in parallel. So OpenMP provides a fairly easy way to make your program use more of the cores on your computer. So by default, if you write in C or C++ or Fortran and you run your program, it'll only use one of your computer cores, which is kind of a shame, because nowadays computers come with many cores. And our computers, our Graham cluster actually has 32 cores on every one of those computers. So it's nice to be able to use that. So OpenMP provides an easy way to mark up various parts of your program and say, okay, this loop you can run. You can break it up into chunks of 32 and run them all at the same time. So this will be going on, again, this, like our courses, you're going to be hands-on and demoing it and covering the items, and then at the end of the course you should have been brought up to sufficient level where you can use OpenMP and dig into the details of the additional features and stuff you would like to use. So OpenMP is a very nice way to quickly bring some parallel threading, multi-threading to your application. So if that seems like something that'd be good for you, you should get in on that course. And it's taught by one of our own again, Jamie Hughes, so he'll be coming down to teach that. At the same time, we have a rather technical course on C++ offered by Paul Prini. So C++, lots of people tend to learn C in and C out, and they think they're C++ programmers, but C++ is a rapidly evolving and adding a lot of features, and it has some real features now that are very sort of performant, aimed at getting very good performance out of your code. So if you're doing C++ programming, you'll probably want to come to this course. Paul has a very deep knowledge of C++. I believe he's on the ISO committee for C++ as well, so that sort of shows you the level of his knowledge of this, and he's going to be going over details such as move semantics to avoid needless copying and object construction, constant expressions, templates, so some template metaprogramming stuff there. And some of the concurrent and parallel constructs, as well as calling into Fortran code and vice versa. So that's quite useful. There's a lot of Fortran code out there, like a lot of the linear algebra packages and such, so to be able to bring that into your code is good. So if C++ is your thing, you're definitely you're going to want to not miss this course here. And then at the same time, so as your, I guess, your light option, but also I hope you come if you just want visualization. Myself and Wei Guang are going to be covering ParaView, which is a visualization software. And again, it's an open source one. You can download it, and indeed you should download it and install it. So we'll be taking you from the basics of running ParaView, so introduction to the GUI and how to, all the different sort of slicing of your data and coloring and that sort of thing. continuing right up on how to do temporal analysis, so that's looking at time and time steps and animations. And then in the second half, we're going to move into getting your data into ParaView, because once you understand how to use ParaView and can see how nice it is to visualize, the next thing you want to do is get your data into it. ParaView supports a wide number of formats, so we'll cover that, and then also covering how to convert your data into a format that ParaView knows in case it's in some odd format that it doesn't. Seems there's an endless number of possible formats data can be in, so that'll get you to visualizing your data, get your data in there and get it visualized. So this brings us to our final day of the week, Friday. So in the first option here is going to be Debugging and Profiling by Sergey, again one of our own. So he's going to be looking at the tools that you can use on the clusters for debugging and profiling your parallel programs. And really, to get the best performance out of your parallel programs, you really need a good tool. Can make a huge amount of difference, tell you where to focus your effort and help you know what's going wrong. So if you're doing any of the more low-level programming, again, C++, MPI, C, Fortran, OpenMP, CUDA, for sure some point in your history, your career, probably fairly soon, you're going to want to be able to dig in and figure out what's going on, why it's slower than it should be, or how best you could speed it up, or why you're getting weird results, or how come it crashes. And it's very useful to get a handle on these tools that can make your life a lot easier in this circumstance. Now, as sort of another kind of course, much like the C++, but this time focusing on Fortran, we have Bao Lai, who will be presenting this. He's one of our colleagues here from Western. And he's going to be going into Fortran, and this is interesting. Lots of people think Fortran, and they think the old Fortran with, fixed line widths and items like that, going back to punch cards and such. But Fortran has been, it has been advancing. In fact, there's a 2018 standard and a lot of modern features. Fortran still ranks as one of the best languages to do numerical development in. Lots of the languages, like C, for example, are actually more aimed at writing operating systems than writing numerical scientific code. Fortran is aimed at writing numerical scientific code, and that can make a big difference when you're trying to do stuff like matrix programming and working with numbers. So he's going to be going over Fortran and a lot of the new features. And in particular, I'd like to, and also again, flip side, calling C and C++ this time for interoperability, but I'd like to draw your attention to the end here, the co-arrays and co-routines. For easy parallel processing on distributed memory systems. So Fortran has, the latest standards has built-in support for co-arrays and co-routines, which allow you to express some of these parallel computations at a very sort of high level and intuitive, so you don't have to get into necessarily the MPI nitty-gritties of moving stuff around yourself that you're forced to in a language like C. So that's an interesting thing to keep an eye on. So for certain, if you're interested in seeing, dispelling your sort of mythical ideas about Fortran being old and clunky, come to this course. Or maybe you're just working on Fortran, or you've learned Fortran from your supervisor who learned it from their supervisor who learned it from their supervisor. So you're actually writing according to, the Fortran 1977 standard. You can be advanced quite a bit by coming and jumping up to the 2018 standard. Come to this course. And then our final option, we're going to have some machine learning on the third day. So sklearn and TensorFlow, this will be by Guang and Jose. And these frameworks are generally built in Python, so helpful to have some Python basics. So if you want to attend this, it might be, and you haven't had much Python, it might be a good idea to catch the first day's Python. And then, of course, some just basic understanding of calculus and linear algebra is necessary for machine programming, machine learning. So machine learning is actually, there's sort of more traditional machine learning, and there's more the sort of hot machine learning, which is the deep learning now. So this course will be looking at both of these. and by looking at real problems such as predictive analytics and recognition of handwriting and classifications of flowers and using our cluster. So the first half is going to be focused on the regular machine learning, which uses the sklearn package, and the second half on the deep learning with TensorFlow. And also going to explore the how you set up your networks and your network architectures and your training parameters, and using the GPUs and the CPUs and such on Graham to get the best performance. So if you're into machine learning, or you're just interested in hearing what the really sort of hot topic of machine learning is about, get an idea, you should come out to this course.
Can I jump in, Tyson? Just
yeah.
Very briefly, a couple of logistical issues. So I'm Sergey Maschenko, one of the staff involved in summer school. So unfortunately, our courses have a limit, which is 40 students. And it looks like 2 courses are already full, which is Python and machine learning. I mean, it might change. Maybe people will cancel. But if you're interested and it's full, you cannot register, just send us an email. We will add you to waiting list. So there is a chance there. 2 courses which are almost full are visualization part of you and R. Again, so you probably should hurry up if you're interested in one of these 2 courses. And so there is a general requirement. Everyone should bring their laptops for all courses. It's pretty much a requirement because all courses have a hands-on component. And everyone should have SSH client, which is already available under Mac and Linux. But for Windows, you need to install something like Mobex Term application, and some of you might need also X window interface for visualization, I suspect, and debugging. And if you're a Mac laptop user, you will need to install X Quartz application for that. But more instructions will be sent if you are registered right before the summer school. Finally, the carpool Tyson mentioned. Send emails to me. So I'm one of the organizers. My email is syam@sharcnet.ca. Again, syam@sharcnet.ca. So far, no one contacted us, but we can help you to arrange carpooling if you're coming from Waterloo or McMaster, where I'm located, from nearby campuses. That was all I was going to say.
I'll just throw in on there as a side note about our courses being full. So that's room size restrictions. So please, if you've registered and it turns out you're not going to attend or something, let us know, because there's people who are wanting to get in, and traditionally, if we don't. So there's a whole question of whether we charge for registration or we don't charge for registration. If we don't charge for registration, it seems about half the people who register don't actually show up on the final date, which is a real shame, because we'll have turned down a lot of people who wanted to get in that class and would have attended. So please let us know. And if the class is full, I guess, and if you're here anyways, you could hang around for the first little bit of the class and see if there's empty spots and sit in that way as well, because there'll probably be people who have registered and don't attend and don't let us know that they're not going to attend. We can't stuff more in, though, than the room limits due to fire regulations. So.
A quick note here, for anyone registered for summer school, please check your email. There's a validation, email validation link in your email. Your registration won't be complete until you click the link and complete the validation. So just so I know.
I should probably mention this as well now that I'm looking at this list. So a lot of our courses had assumed some basic familiarity with Linux and the command line. If you haven't had much experience on the cluster and it works into your schedule, we're teaching an HPC carpentry course in Conestoga, so that's Waterloo, on the Saturday and Sunday before the 26th and the 27th. So that's an excellent course to come to get a bit of hands-on using the command line and the clusters, which set you up well for the summer school if you're really fresh and don't have any of that sort of Linux cluster or using our supercomputer experience. So again, that's the the Saturday and the Sunday before the summer schools begins.
So just a reminder, the HPC carpentry is in Kitchener. It's not in London. So it's in a different city. So you would have to, if you wanted to attend both, you would have to basically organize transportation for yourself on Sunday from Kitchener to London.
Yeah, that's right. It's a separate event. Well, I guess maybe we will can shut it down then. If any questions come up, you can always contact us. You send an email to help@sharcnet.ca. We'll get that. And I hope to see you guys all on the last week of May there for some exciting courses.